recording here, we're actually going to say answer here, P. Now, this is not a problem that you're going to see in my class, but hopefully, as you're getting ready for colleges and such, this is a problem you will see on the SAT. Okay, now, you do have a lovely calculator, and we have done absolute values in the calculator before, so let's just review quickly where that's at in the calculator. Okay, so I'm going to clear anything on my screen just so it's clear. But if you click on your math key and go over to num, up comes ABS. That stands for absolute values. And if I click enter, that's what I get. So I'm actually just going to type in everything they wanted me to type in, which was -5 squared. Key thing here, though, you had to put parentheses around the -5. If you don't do that, it actually means 5 squared. Stick a negative on the outside. -25, and if I click enter, you can see the answer. Oops. Sorry, not -25, it's minus what? 50. It'll give me the right answer of 25. Okay? Now, did I need to use this? Absolutely not. But, for anybody that needs to retake the keystones, that can be a helpful little tool right there. If you need to retake them, that's coming up in January. Okay, any questions? Lovely. Let's go ahead and turn to the front of our spiral notebook. So, what's the inverse of adding? Subtract. What's the inverse of multiplying? Dividing. Alright, so we understand the inverse of multiplying, the inverse of adding. And in fact, if I add two numbers that are inverses of each other, 3 and -3, they're inverses of each other, right? What number do you get? Yell it out.
0.
Perfect. If I multiply two numbers that are inverses of each other, what do I get? 1. The same is not true of the matrices though. They use both of these numbers when you're finding inverse numbers. Now we just talked about the identity number for both adding and for multiplying. But now we have to talk about an identity matrix. So make sure you write the word identity matrix down. And the identity matrix will actually use both the numbers 1 and 0. Let's start with a 2 by 2 identity matrix. I had that pen a little too close. Let's start with a 2 by 2. The identity matrix has 1s going from the top left to the bottom right. And then the other spots are all zeros. That would be the identity matrix for a 2 by 2. Any questions? Let's do a 3 by 3. So the same rules apply. I'm only putting one diagonal of ones in, starting at the top left, and going clear to the bottom right. All of the other numbers become zeros. You guys do this for like a 5 by 5? 6 by 6? Okay. How about do one more for me? A 5 by 5. Make the identity matrix for a 5 by 5. Identity matrix for a 5 by 5. That's the answer. That's it. One's going in a diagonal and all the rest are zeros. Raise your hand if you got that one. Excellent job. So now let's actually find an inverse. Go ahead and copy that matrix down. So the first thing we have to do in order to find an inverse though, find the determinant. So I'd like you to find the determinant but without using the calculator. Find the determinant but without using the calculator. So in order to find the determinant, for anybody that forgot, you multiply these two, and then you subtract after you multiply these two. So my answer is 2. So you have the first part that you need to find the inverse. And what you actually do is you take 1 over whatever the determinant is. And that's going to be my scalar. If you remember back to the week before break, we actually talked about a scalar is just a number that gets multiplied by the matrix. But it's not going to be the original matrix that we multiply by. We've got to rearrange it and switch some things around. The 3 and the 2, they actually switch places. So the 3 and the 2, they switch places. The 1 and the 4, they change signs. So -1 and -4. Any questions so far? No? Then we just multiply. What's half of 2? Half of -1. -1/2. Half of -4 is -2. And half of 3, 3/2. That make sense? So right now I'm going to show you how to do this by calculator. The first thing we all need to do, we need to enter this matrix into matrix A, the original matrix, the 3, 1, 4, and 2. 3, 1, 4, and 2. Let me see if mine is still in there. Second matrix, you go over to edit, hit enter, 2 by 2, okay, that's perfect. Then get back out, go to the home screen. If there's anything on the home screen, clear it. I like it when it's nice and clear. Call up matrix A. Second matrix, enter on letter A. And now, you actually only need one more key for inverse. And that is this key right here that I'm pointing to. Now click on it, now it turned red for you. And that's what appears right beside your matrix. That little -1 sign actually means inverse. At this time, go ahead and write yourself a note about that little -1 sign. Because in chapter 6, we're actually going to find inverse functions. And every time you find an inverse function, you actually write that little -1 sign with it. That little -1 sign, once again, does mean inverse. After you write yourself a note, go ahead and hit enter. Hey, isn't that the matrix we had found? Except our matrix was in what kind of thing? Fractions. How do I change that to fractions? Yep, math. Enter, enter, good. And that's the exact answers I came up with. In case for some reason your inverse is like 2/3, which is actually 0.666666667, you'll want to do that. It'll change it to a fraction for you. I wonder what happens if I multiply A with its inverse. So what I want you to do right now, type this into matrix B for me. So I notice that if I take a matrix and I multiply it by its inverse, I get the identity every single time. Any questions? So I have a question for you. I'm going to go back to this screen here. When can I not have an inverse? Okay, that's actually right. So I can't do an inverse if it's a 3 by 2 or a 2 by 3. It has to be a square matrix. When else can I not have an inverse? Just one other time. That's, I think, what she just... He's close with determinant. What can the determinant not be? It can't be 0. If your determinant is 0, there's no inverse. Because then you'd be putting 1 over 0, which is undefined. That make sense? All right, here's our next problem. Take a second, copy that down. So here I have a lovely matrice problem. That capital X does mean I'm finding another matrice. Now, what we just talked about a second ago is that you cannot divide matrices. So I can't just divide the second matrix by the first. That does not work. So what I need to do, though, is I need to find the inverse of one of them. So what I'm asking everybody to do is to put that first one into A and that second one into B. So, like I was just told, I'm going to need to take the inverse of the first one. So I'm going to do A inverse B. Can I switch the order? Can I do B times A inverse? Do you think that'd be the same thing? No. Remember, matrices you can't switch. Okay? You're not allowed to switch them around to multiply them. So it has to be in that order. Now, I would say you need to write down that lovely equation right there and put a star around it. Because if you end up having to take the final, whether you have to take it or not, you have to do the review. When you go to do the review, that is one of the review questions right there. So there is our lovely answer. Raise your hand if you got that answer. Wonderful. How could I check this? What would I have to do to check this? How? Okay, yes, I would check it in the calculator. How? That's it. So how about this? I'd like you to put this in the letter C. And I want you to multiply A and C and see what happens. So right now I have you putting this into your calculator, and go ahead and find the inverse for me using the calculator. And you don't even have to write down the answer. I just want to make sure you guys can do this all in the calculator real quick. So telling you just to do this all in the calculator is actually a ploy for another question. Last question of the day before I give you the homework. Are you ready? Knowing what you know now, knowing these two are inverses of each other, if I said multiply them, and I said you're not allowed to use your calculator, discuss with your group what the answer would be. So if you multiplied these two together, you should get the identity matrix for a 3 by 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. No calculator needed, right? All right. At this time, here is your lovely essential work. You can get it all done now.